So for the second part of section 4 here, we had worked out using the empirical rule, 68, 95, 99.7, all the individual little percentages. So 34 and 34, 13.5 and 13.5. We'd said 68, cut it in half, that's 34 and 34. We'd said if I go out again, that's 95%. You could even do 95 minus 68 divided by 2 gets you this 13.5%. That's one way of finding it. Or we've done, okay, cut it in half first, 47.5 minus the 34 gets us the 13.5. Go out one more set, 99.7. Half of that was 49.85, and then subtract the 47.5 to get this. However you want to get those percentages, the idea is to take the empirical rule, the 68, 95, 99.7, and distribute it in chunks all the way along our 100% bell curve. Does anyone have questions about where these percentages came from? Because once you've got them, the work itself is pretty easy. So let's go down here and look at number 3. So this is number 3 in the notes. I'm going to put the percentages in, knowing that they do not change from what we did before. So here is the middle. This section right here should be 68%, right? The red piece is going to be 68%. Half of that would be 34 here and 34 here, right? 68% is this whole thing in here. I cut it in half, that's 34 and 34. If I go out another standard deviation, 2 standard deviations out, that's supposed to be 95%. So 95%, you could do 95 minus 68 divided by 2, gets you 13.5%. 13 point, let's rewrite that a little bit clearer. 13.5% there and 13.5% there. If I go out 3 standard deviations, that's 99.7%. If I do 99.7 minus 95, that gets me 4.7%. Take half of that. This little piece right here is 2.35%. And this piece over here is 2.35%. And then the only thing left over, the only pieces left over are those little wings on the end. Everything above is half of 0.3, right? That's all that's left over right now is 0.3%. Half of that is going to be 0.15% on this end, and the little tail on this end, 0.15%. Those percentages do not change. Are we okay there? Any questions about how we found those? They're exactly the same as the other ones. You're always going to get the same percentages. Sky, you look a little concerned. The 2.35? So this one right here, or 13.5? The 13.5, there's 2 ways. You can do 95 minus 68, which I think is what, 20, 23, is that right? No, it's not. 20, it'd be 27, right? Well, okay, depending on how you subtract it. 95 minus 68 should be 27. Does that make sense? Cut that in half. Half of 27 would be 13.5.
I did it 16.
Yeah, that's fine, as long as you know that it's a positive percentage. Now, those numbers don't change. The ones that change are the bottom numbers, which are the labels for each of those dividers. The mean goes in the middle. So they tell us the mean is 24 this time. So that goes here, 24. And then we count up by standard deviations. So I'm going to go, let's see here. I'm not sure what colors I haven't used at this point. The standard deviation of 4 means I'm going to count up by 4. So 24 plus 4 is 28, 32, 36, and then count down by 4s, 20, 16, 12. Those are the numbers that change each time. Does that make sense to everybody as well? So we took the mean goes in the middle, and then we counted up by standard deviations. So this time the standard deviation was 4, so I went up by 4s, and I went down by 4s. Now I'm all set to answer my questions. So letter A asks me, what percent of scores are between 12 and 20? So here's 12, here's 20. I need this one plus this one. Those two are in between 12 and 20. Do I see everybody's eyes up here? Is that making sense? Between 12 and 20, we're just doing 2.35 plus 13.5. 2.35 plus 13.5 gets me 15.85%. It's only the ones in between those two values. So similarly, if I want to go from 24 to 32, here's 24, here's 32. The two in between those are 34 plus 13.5. So that's what I'm going to add together. Yep, 34 plus 13.5 is 47.5%. Now, if they ask you for one that's less than or greater than, not between, so like if you look at letter D, less than 16, here's 16, go less than that. Well, that's these two numbers. Those two are less than 16. 2.35 and 0.15. Those are the only two that are less than 16. So I add those together. So 0.15 plus 2.35 makes 2.5%.
Did you skip C?
I did. Yep.
Why?
Because we don't need to do that. I'm hoping because it's the same as A and B. Now I'm going to skip some more. I'm going to skip down to letter F.
Wait.
Yeah, I'll leave that up there for a second. Yes. Yeah, it's real simple, right? That's why I'm like, most of you can do that one. Let's skip and focus on the ones, yeah, that we might have some questions about. So let's look at letter F. Does everybody see that letter F asks a different question? Letter F says, how many are between 24 and 28, or score between 24 and 28, instead of the percentage? So I come up here, I find 24 and 28. Here's 24, here's 28. That's 34%. Sorry, I said I was going to do, which one did I say I was going to do? F. Okay, good. All of a sudden I was worried I did the wrong one. So that between 24 and 28 is 34%. So you find the percent just like we did before, but then you have one extra step. Take that percent out of 100 and set it equal to the number X out of the total number. So X out of 800. And then you can cross multiply. X times 100, 100X equals 800 times 34. 800 times 34. So 800 times 34 is 27,200 equals 100. I should not put those in a different order. That's going to confuse people. 100X equals 27,200. Divide by 100. Divide by 100.
Equals 2.
Yes. 272.
I wanted to be sure though.
Yeah, so
Can I
272.
correct myself? Make sure I'm doing it right now.
Yes.
You know, this is why I didn't do it at Starbucks.
We're gonna be going on to the next section in a
No.
second. So,
We have to do it after. Say no.
real quick, I forget if I told this class or not. What if I got 271.5? What would I have done? So the trick here is normally we think of rounding up, right? 0.5 or higher. But in statistics, at least the way we're going to do it, again, a different teacher might do it slightly differently. This one's a little bit ambiguous, but what we're going to say is that last person didn't make it. They didn't get the score they needed. Does that make sense? So we cut them off. So if it was 271.9, it's still only 271 students that made that score. Does that make sense to everybody? Just cut off any decimal. All right, you guys, I want you to try this now. Go to the homework and let's try problem 3. Try problem 3 on the homework.
I'm trying to.
Try number 3. So those of you that are still wrapping up with the problems there, like number 3 on the homework, a quick note. When you're finding the percent or the actual number, the approximate number, I showed you how to do percent over 100 equals X over the total, cross multiply. That way works perfectly fine, and it's based off of what we were doing last unit. So it's a great thing to do. There are other ways. If you remember back in junior high how to find the percent of a whole number, you can do essentially percent over 100 times whatever number you're given. So like right here, the one that we did right there, 34 over 100 equals X over 800. You could also just do 34% is 34 over 100, 0.34 times 800. That will also work.
I did it wrong.
So
I did H instead of G.
that's okay, just draw an arrow.
That's gonna confuse me.
But for now, go ahead and leave it. And let's look at the very last section. So the last page of your notes, Z-scores. You can turn to Z-scores, but I'm actually going to point out a couple of things before we do that on the previous problem. You don't need to be on this page. You're not going to write anything down. What if I asked you what score, so this is, you're going to look at the last page in just a moment, but I'm going to connect what we're about to do with what we just did. What if I asked you, what's 2 standard deviations below the average on this distribution? What's 2 standard deviations below the mean? 1, 2, 16. 16, that value is 2 standard deviations below the mean. Does that make sense to everybody? And if I said, what's 3 standard deviations above? 1, 2, 3, that'd be 36. Is everybody good there? For just saying, if I'm describing something in terms of standard deviations. So if I say what's 1 standard deviation above the mean, above the average, 1 standard deviation up is 28. Does that make sense? It's 1 notch up. What if I ask you what's 1.5 standard deviations up? Could we find that? So here's 1, here's 2. What's halfway in between? Did you find that right? 28 plus 32 divided by 2 would be 30. 30 would be 1.5 standard deviations up. We can also talk about it the other way. How many standard deviations below the average is 12? 1, 2, 3. Does that make sense? That number that we are talking about right there is called the Z-score. The Z-score tells us how many standard deviations away from the average we are. The wonderful thing about the Z-score is it helps us describe where something falls in a data set without really caring about the data set itself. It says, okay, here's my spread. Is this a low score or a high score? Does that make sense to everybody? Now, let's go ahead. Hang on for just a minute, okay? I can go over that in a little bit. But right now I want to talk about Z-score. So the Z-score, I'm going to give you this formula on the test, but I'm not going to label it like it's labeled here. Does that make sense? because I want to make sure that you understand it. I want you to be able to do the work. Yes.
Like the other thing, that we're coming back from Thanksgiving break. So you want us to study basically.
Okay, we'll talk about that. We're gonna have 2 days to review when we come back. So it's not gonna be right afterwards. You don't have to study, but we'll talk about that at the end of class. Right now, I want to make sure we get through this. So the z-scores. This takes, focus. Yes. The actual value minus the average. So what's the score I'm looking at? Minus the average divided by the standard deviation. That's my z-score. It tells me how many standard deviations away from the average I am. So let's try it. It says an exam produced grades with a mean score of 78.4. That's the average. That's mu. Write it down right now. This is mu. That's my average. And a standard deviation of 8.5. That is sigma. That's my standard deviation. So now, let's go ahead and put those into our formula along with the actual score. So, Anthony, we're on the last page of the notes. So I've got my standard deviation, I've got my average, and I have a test score. So if the test score here is 45, I'm going to plug that in right here. The actual value is 45. And I'm going to subtract the average. So minus 78.4. X. X is the test score. We're finding Z. It's okay. Divided by the standard deviation, 8.5. And you're just going to plug this in a calculator. If you're doing a calculator that does a scientific calculator that does order of operations, make sure that you do the top part first and then divide by the bottom.
Did you get negative? Like at 33.4.
Close. So I'm going to do the 45 minus 78.4, which gets me negative 33.4. And then I'm going to divide by 8.5.
Yeah, you get negative 3.9.
Yes.
Uh,
So what we should get here
yeah,
is negative 3.976.
3.92.
But the instructions tell us to round to the nearest hundred. So we're going to say that my z-score, the z-score is negative 3.98. Does that make sense to everybody?
You said negative?
Negative 3.98. Now, they're going to ask us, oh, I divided by the wrong number. No, I didn't. What happened? 45 divided by 8.5. 3 point, so what did you get? Okay, let's figure out what's going on here. So 45 minus 78.4. Do we all get negative 33.4? No? Divided by 8.5, 3.929. Okay, I don't know what happened there. Did I write these all in? Those are all written correctly. So 929, which is going to round to 3.93. Okay, I apologize for that. Thank you to the two of you for making sure that we had that right.
Extra credit. Oh, extra credit. Oh, I don't want to get up to go quite.
Now, we're going to use a stock phrase. Focus, focus. We are gonna run out of time, you guys. I know this is the last period before Thanksgiving break, but we still gotta finish this. So the stock phrase, when we describe this, we're gonna say a score of 45 is 3.93 standard deviations below the average or below the mean. Why is it below? Because it was negative. Does that make sense to everybody? So I plug in the numbers, I calculate my z-score, and that tells me how far above or below the average I am. Now, is that a good score?
No.
No, it's not just a bad score, it's a horrendous score. Remember that our graph only goes out to 3 standard deviations down? This is almost 4 standard deviations out, which means if we had like 1,000 students, this is like the lowest, like 1 out of 1,000. It's a really low score. Does that make sense to everybody? Let's skip B and do C.
Why?
Because we have been talking too much and we're going to run out of time. So look at C. B is exactly the same as A. B is exactly the same as A. Let's do C. So for C, I'm going to plug in the same numbers. The 85 is my test score. So I start with 85. I subtract the average.
78
So minus 78.4
divided by 8
divided by the standard deviation, 8.5.
equals
Everybody go ahead and plug it in, get an answer. When you get it, you can shout it out. So 0.776. So round up to 7.8. Everybody check, make sure that's what you get.
78.
So we're on the last page of the notes.
And again, we have a stock phrase to explain that. We're going to say,
A score of
yep, a score of,
85
there you go. It's again the same thing every time.
is 78
0.7.
below the mean.
Oh, careful.
Above.
Above.
Come on, girl.
A score of 85
Anthony, I said more than
is 0.78. Let's not turn it into a competition. We're all doing well here. Let's keep going. So 0.78 standard deviations above the mean
Why is it above?
because it's positive. If it's positive, it's above. If it's negative, it's below.
Wasn't the first one positive?
First one was negative. It was
Then why do
negative
we put the negative
3.93 because the below takes its place. If you want to put the negative there, you're welcome to. I won't count that as wrong. But when I'm saying below, that's describing go negative. Does that make sense? That's why I'm emphasizing that. Is it above or below? Okay, let's skip down to number 2 now. A sample of textbooks has a mean price of $150 and a standard deviation of $30. Find the textbook price that goes along with the z-score. So this is backwards, right? They are giving us the z-score and we're going to find the actual value. So if I set this up, z-score, skip letter A for now, do letter B. 1.6 equals, so 1.6 equals the thing I don't know. The X value minus the average, right? 150
Equals.
divided by the standard deviation of 30. And it's a 2-step equation. You did a bunch of these back in Math 1, right? Multiply both sides by 30 to get rid of that down there. So times 30. Well, here's your chance to get some practice and get better. So times 30 on both sides. 30 times 1.6 gets us 48. 48 equals X minus 150. Add 150 to both sides. And we get 198. X is $198. Any of you have siblings in college right now? or cousins or somebody else, any of them complain about textbook prices?
Yes.
Yeah, so this is not an unreasonable textbook price.
Actually,
They're often between $100 and $200. So also along with that, here's a college probability and statistics book. The front cover often, or somewhere in the book, has something that looks like this. This is a list of z-scores. Yeah, this is what we're doing right now. This would be the next step beyond what we're doing today. What you can do here is look up a z-score, and it will tell you what percent is below that z-score.
oh.
So like here, that 1.6, if I look up 1.6 here, 1.6, 9.9452, that means 94.5% of scores are less than that one. 94.5% of textbooks will cost less than $198. That would be the next step. We're not going that far, but that's the idea of where this would go if you take statistics next year.
Yeah, exactly.
So let's do one more of these. Look at letter C. Z is equal to negative 1.8. So I'm going to set it up. I'm going to stop color coding stuff. Hopefully you've got the idea at this point. Negative 1.8 is equal to
X.
the X that I don't know,
minus 150.
minus 150, which is the average price. So divide, and then yes, divided by the standard deviation of 30. Go ahead and solve that.
You multiply 30.
Multiply by 30. Everybody go ahead and solve it on your own. Let's get an answer.
Cross out. Negative 54 equals X minus 1.
No, there's no sentence that goes along with this one. If they wanted it, you would say that that's the price of the textbook that goes along with
I
that
got
Z value.
96.
There we go. That's perfect. Hopefully everybody's getting 96.
It
If
was
you're
up
not,
here the whole time.
no, I just wrote it.
Oh,
So you can check your work. So 96. These last two, the last two examples, 3 and 4, are how you find the other variables. They can literally give you 3 out of 4 pieces of information and you can solve for the 4th one. So number 3 doesn't tell us the mean. So we set this up, z-score of 2.85 equals the actual value of 2.45,
whoa.
right? They tell us what X is, 2.45, minus the average, that's the one I don't know, divided by a standard deviation of 0.4 or 0.40. So here, I'll walk it through with you. We could multiply both sides by 0.4 times 0.40. So 0.4 times 2.85 is 0.1 or 1.14.
Equals.
Yep, 2.45 minus mu. Subtract, right? 2.45 is positive right now. Subtract 2.45. And I get negative 1.31. But that equals negative mu. And I apologize, those of you who are at the edge, can you all see that?
Why is it negative?
So it was negative because we did 1.14 minus 2.45.
Oh, yeah.
But then we're going to have to get rid of both of those negatives, divide or multiply by -1, and yet the average is 1.31. And then the last one, solve for the standard deviation. So we set this up, z-score of 1.2, X is 326 minus 290. That's the average, the mean, divided by standard deviation. This one, it's probably easiest to just go ahead and do 326 minus 290 at the beginning. Do 326 minus 290 gets us 36. 1.2 equals 36 over sigma. Now I need to get the standard deviation symbol out of the bottom. I'm going to multiply both sides by sigma. So I've got 1.2 sigma equals 36. And I can divide by the 1.2. And I get sigma, the standard deviation is 30. So
You divide by what?
we divide 36 by 1.2 and we get 30. That's sigma, that's the standard deviation. Mhm. The U1 is mu,